Ladies and gentlemen, assalamu alaikum. The challenge we face here is innovation. And I just want to start by acknowledging the tremendous work done, the tremendous leadership shown by His Highness Sheikh Mohammed bin Rashid Al Maktoum, UAE Vice President and Prime Minister and ruler of Dubai. Putting together a meeting of this sort, focusing on innovation, is actually something that I think is an exceptional show of understanding as to what truly matters into driving the success of a nation. Now, what I'll be talking about today is one of the most complex systems ever built to address the need to work with massive amounts of data, quantities of data that far exceed what a human being can work with on their own. In order to do this, though, you need something to really drive you forward, and that's the ability to innovate. Innovation is the #1 capability required to grow a nation, to grow a business, to grow the skills of the individuals who serve you. The thing that's interesting, though, is in 2007, one of the big consultancies did a survey of approximately 9,300 executives asking what helps grow your industry. Roughly 54%, the great majority said the ability to innovate. But here's something that's sobering. In 2010, after the economic crisis, the number of executives who found innovation to be absolutely critical rose to 84%. That's an astonishing number. And the reason, in large part, is people who were not innovating were no longer in existence. Those who failed to innovate disappeared. So this is absolutely critical. I could not agree more strongly with the premise of this conference being to drive innovation in governance. Now, I want to begin a journey getting to Watson. And the journey begins with data, but really big data. And people talk about big data, but it's important as a scientist like I am to put numbers to things. So let me give you a sense of what I mean. Big data is actually quantity-wise so large that a human being can no longer work with it directly. The reason there is so much data, and it's accelerating rapidly as you go past 2010, is that we've introduced new forms of data. Traditionally, data comes in the form of a spreadsheet, of some sort of set of numbers that you're familiar with, of text. But what has happened, as you all are aware, now video is, of course, a favorite form of data, and that takes vast amounts of storage and vast amounts of interpretation, whether it's from cameras that are being used for security, or the 1 billion medical images a year that have to be stored and analyzed. So the quantities of data are massive. Now, the other thing about data is when you put a number on it, it's quite impressive. In fact, the number up there is what's called an exabyte. That is 1 with 18 zeros after it. That is the quantity of data, roughly, we deal with today. But what is very important is this, the rate at which data is being generated. The really sobering statistic is 90% of the data in the world today did not exist 2 years ago. 90% of the data in the world has been generated just in the last 2 years of the history of the world. So it's an extraordinarily accelerating pace, and we must keep pace with it. In governance, this is the challenge you face. Now, in order to work with and understand big data, we recognize the need to create new tools. We need tools to do this, and the tools that we have created are data analytic tools. Data analytic tools solve a basic problem because I am certain that you have had this experience, which is it looks like you have all the data. Where's the delay? If you have no data, you can't get an answer. But also, if you have too much data, it is not possible to get an answer. So the key here is to have tools that help you accomplish that task. The other thing about big data that is remarkable is data analytics is an entirely different view of data than the old view, which we used to call data mining. Data mining, we actually would look for the needle under a haystack. You look for the one important fact that was your answer. Data analytics works completely differently. Every piece of data, every piece of hay in this immense haystack has value, and you have to knit that into your answer, knit that into your needle. So that is the challenge here. All the data has to somehow be accounted for. The question is, why is it so important to have analytics and the ability to deal with big data? Now, this is a good question to answer because you see, IBM invested approximately $25 billion in developing these tools to work with big data. We purchased approximately $17 billion of companies in the last decade that have tremendous expertise in analytics, and we spent an additional $8 billion within IBM to accomplish the same goal and add more skills. The reason it's important is here. One example, changing the future. Rio de Janeiro, the city in Brazil on the coast, faces an enormous challenge every year during the rainy season. In 2010, there was massive flooding, unprecedented flooding, resulting in the death of over 110 people and massive destruction. The mayor and the government said, this is intolerable. We cannot allow this. And they asked us to work on a program to hopefully avoid this ever happening again. In order to do this, you have to be able to accurately predict the future. So the first thing we did is we actually built a supercomputer capable of 24 hours in advance determining the rainfall to within 1 square kilometer. To give you an idea of how challenging that is, in the United States, our National Weather Service will tell you the rainfall within 144 square kilometers. We get it down to 1. It's enormously accurate. We then take those predictions of rainfall and we generate maps to show where there will be the maximum amount of rain. We then get data from the government on the topography, the hills and the valleys of Rio de Janeiro. We get more data from the government on every street in the city to ensure it's paved or it is not paved. Are there houses on the edge of the street? Are there no houses? We take all of that data and we make predictions of flooding. We can now accurately predict approximately 24 hours before the event where the government needs to take action through a center and move people out of the harm's way, out of way of the flooding, so that there will be no deaths, there will be no destruction of lives. You can rebuild a home, you cannot rebuild a human. And it's unacceptable that things like the floods of 2010 should ever be repeated with the same disastrous outcome. So this is why it's important to have data analytics and the tremendous ability to compute required to run an operation like this. There are other good examples. For instance, Singapore. In the US, on the left side, we typically study traffic simply in terms of tolls. We collect money as you pass a point. In Singapore, they monitor the position of cars at every point in the city and how fast those cars are traveling. By doing that, we can take data on every car, every road, all the speeds, all the locations for a year. With this massive amount of data, we build models to predict what the traffic will be in the future. If we see the traffic at a time, I can predict 10 or 20 minutes from now what the traffic will then look like. But if I can predict the future, I can actually tell you there will be a traffic jam in 20 minutes, even though there is none now. But if I can tell you that there will be a traffic jam, I can also take action by changing the cost of traveling on a road, by changing the actual sequences of lights to eliminate the traffic jam. The key is, can you accurately predict the future? These are very interesting and very simple plots. There's simply 3 different locations in the city of Singapore. The blue line is our prediction of how many cars will arrive in 10 minutes' time. The black line is the actual data taken 10 minutes later. You will notice there is absolutely no difference between the prediction and the actual data. And we can do this about 20 minutes ahead as well. Similarly, the bottom, those are 3 different locations, and it is the speed at which cars are traveling. In the last one on the bottom right, you can see there is a sudden decrease in the speed of cars as there is a traffic jam. The remarkable thing is we can actually manipulate the lights and the cost of entering the city through various portals to eliminate that traffic jam ever happening. We can predict the future and change the future. It sounds like science fiction, but it is not. Your traffic report is remarkable. It used to be, you would say, you are stuck in traffic, and here is why. You can now say, you would have been stuck in traffic, but we fixed it. It's rather unusual. I prefer the second report personally. I live in New York, and believe me, we understand traffic much like Dubai. Now, in public safety, you can apply the same things. Using analytics, working with the city of Richmond, Virginia, and we also did this with several other cities, what we did was we tracked the occurrence of thefts, the occurrence of break-ins to cars, and the occurrence of robberies. Every 4 hours, we gave the police a prediction of where the activity of criminals would be. They did not hire additional police. They simply reallocated their resources to the area we would predict there would be a problem. A fascinating thing happened. In the first year of the program, there was a 32% drop in violent crime. The second year, a little fast there, the second year, there was a 40% additional drop. The city of Richmond, Virginia went from the 5th most dangerous city in the United States down to number 99. Again, this is why we have such a focus on analytics and what it is possible to achieve with them. This is an important document. This is something that I actually asked the entire information technology industry to pay attention to. The Ebola crisis ravaging Africa is a case where we all need to step up and engage. We have resources in a lab in Nairobi, Kenya, with access to great data analytics. What we asked the government of Sierra Leone for, and what they very quickly gave us, is data. They actually had their operators from the Open Government Initiative take phone calls with information about crises in Ebola. We had SMS messages, which we would take anonymously with information. Once a day, we would create what's called a heat map, where we would show, for instance, in red, where there was great danger, where there might be somebody who had passed away and needed to be removed and buried, where there might be blood. We would show where there were shortages of supplies, where people might need bleach in order to sterilize things, where there was shortages of electricity, where information was needed. And we delivered this so that the government could put its people in the right place immediately because they have limited resources with which to fight the epidemic. Again, the use of analytics is extraordinarily powerful, and it is in use today, and this is at the heart of Watson. When people say, what is Watson, what's inside, among the other aspects is we have very strong analytics engines to get the right answer. There is a challenge, though. All the cases I've shown you are before Watson, and they are done by experts. Notice what I said about Ebola. The data went to a laboratory we have in Nairobi, Kenya, and experts ran the system. That's not good enough. To adequately serve our population, This must be accessible to everyone. You should not need a PhD in computer science. You should be able to simply address a system, ask a question, and get an answer. That is consumable, and that's key. The basic idea behind information technology is it should ultimately become invisible. You simply take it for granted. Enabling this era of what I call accessible intelligence, this is what we call cognitive computing. It's computing that is much like a human's thinking. Now, Watson actually was named after the founder of our company on the top left, Thomas J. Watson Sr. That was a machine that was the result of a very interesting challenge from Sony Corporation. What they said was, if you think this question and answering system can compete with the two best champions ever in this game called Jeopardy, we will allow you to compete, but you have to promise, no matter how much you struggle, you will go on international television and either have a tremendous success or perhaps embarrass yourselves in front of 100 million people. Rather than show you the end result, let me show you the work that went on to make this happen so you really understand the unbelievable challenge this presented. And let me explain briefly, the game Jeopardy is a little strange. The host actually says the answer, and the contestants have to say what the question was. So as an example, the host may say, he was the first American president with wooden teeth. And the answer would be George Washington, who actually was the first American president who had wooden teeth. So with that as a bit of a guide, what I'd like to ask the team in back to do is run the video, What is Watson?
It's going to change how we interface with information.
People are going to ask, how did it do that? How did it accomplish this task, which before we thought only humans could ever hope to do?
David Hume held this view that sense and experience are the sole foundation of knowledge. Watson.
What is empiricism?
Watson is a question answering system. A question can be posed in natural language, and having read a whole bunch of information, data, documents, come up with a very precise answer to that question.
It's an information-seeking tool that's capable of understanding your question to make sure that you get what you want, and then delivers that content through a naturally flowing dialogue. Do you have one of those? I don't have one of those, right?
It's a human standing there with their carbon and water versus the computer with all of its silicon and its main memory and its disk.
After Germany invaded the Netherlands, this queen, her family, and cabinet fled to London. Maria.
Who is Beatrix?
No. Watson?
Who is Wilhelmina?
That is correct.
Humans communicate very fluently in natural language. And that's where computers struggle dramatically. And that's where we want to make them better.
This U.S. president negotiated the Treaty of Portsmouth, ending the Russo-Japanese War. Watson.
Who is Theodore Roosevelt?
Good for $800.
Jeopardy questions are tricky. They have puns in them, they have little jokes in them.
A famous red-coiffed clown, or just any incompetent fool. Watson.
Who is Bozo?
Nice. Good job, Watson.
I think we've gone from impressed to blown away.
This is really remarkable performance. And we know of no computer system that can come anywhere close to doing this question-answering task.
Watson is the confirmed champion for this game.
But the reality is that being able to win a game at Jeopardy doesn't mean you've completely conquered the language understanding task. Far from it.
In REM's It's the End of the World as We Know It, two of the men with the initials LB Watson?
What is I feel fine?
Ooh, no.
The worst thing is if Watson just crashes in the middle of the game. That's what you don't want. But then the second worst thing is if you have some horrible bug where Watson starts getting everything wrong.
What are trousers?
No.
What is harness racing?
No.
What is taxi to the dark side?
No.
What is artificial sweetener?
Come on now. No.
What is milk?
No. Very nicely done.
We both beat them.
Good for you.
Humans. Woo.
This is triage. There's a million things to consider here. This is just one.
We're going to run out of time. We're going to run out of time.
Our responsibility to the scientific community is to push this technology as hard as we possibly can, because when we get out there in public, what we're demonstrating is what is the state of the art? What can we really do?
It's limitless, the number of things you could potentially apply this to.
Watson, you have control.
Professor Schwab yesterday gave a great example of the leadership you need sometimes to tackle the really hard problems. And his last comment was, you need nerve. This took nerve. The poor machine was getting lots of things wrong within weeks of having to compete on global television. The beauty of it is that these people had the courage to work day and night and solve the problems that we had. And the capabilities of Watson are beyond imagination if you look at some of the things I'll show you later. But this is how innovation happens. People show great courage in the face of a challenge, in the face of what potentially could be extraordinarily embarrassing and perhaps what we affectionately call a career-limiting episode. What is remarkable about Watson is it ushers in a new era of computing, which is the cognitive systems era. For many years, we simply had tabulating systems, which are adding machines. Now we have programming systems where the typical computers you have are programmatic. But the cognitive systems have something absolutely unique about them. On the left are the more limited programmatic systems. They basically use traditional data, structured data like numbers, and they basically follow a program. You tell it what to do, and that's it. It does the same thing each time. A cognitive system is unique because it learns. It can customize itself to your behavior. It actually has the ability, when corrected, to internally say, aha, I have to do this differently next time. And the one thing that most people have trouble comprehending is you teach a cognitive system. You literally teach it like you would a young child. You educate the system. When it starts, it has all the data, but it doesn't know what to do with it. You literally have to teach the system. And I'll show you in a moment where that's actually going on now publicly. Now, how does a cognitive system work? It works much like a human. Initially, you ask a question, and through what's called natural language processing, it takes the question and looks at every possible interpretation of that question. It then takes all those interpretations and it comes with every possible answer, hypotheses. It says these could be the 150, 250, even 1,000 potential answers. But then it does something unique. It takes this vast body of knowledge that you fed it, and it actually calculates the probability that each one of those potential answers is correct. And in the end, from all of this learning, it actually ranks the answers from most probable to least probable, many times only presenting one or two answers because it has a very high 95, 98% probability that it is correct. This is, again, something that is learning, so that after going through, if it is wrong, you correct it, it goes back and revisits the problem. The things that it has introduced that transform the industry is, first, you deal with it in natural language. You do not need to be an expert. That is a tremendous change in information technology. The second part that's really transformational is it literally goes through and ranks the answers. It comes out with a best answer, many times a sole answer, much like when you would be working with a person who is an expert. And the third fundamental change is it learns. These are really the three basic ingredients that make Watson unique. What I'm going to do is take a risk. Normally, when you do these sort of presentations, you have things in back on a video, and I've decided that instead of doing that, I'm going to actually run live examples of Watson in addition to taped examples. The first example is an actual example of Watson working with a person who is changing his insurance. He will call using an app on an Apple iPhone. I do apologize to the CEO of Samsung, but I assure him that I have a Samsung device. Nonetheless, the demo will be on an Apple iPhone. And a person, this fellow, is getting married, so he wants to change his insurance. His wife will be moving in. He needs to increase his insurance coverage. He will ask about insuring some of her jewelry. But what happens is it's a give and a take. He asks Watson's questions. It gives him answers. Then Watson asks him questions. He gives Watson answers. And then he starts asking questions that are totally, as they say, off script. They're not questions Watson raised. And Watson has to quickly look through all of its data and give him the correct response. So I will first run that demo, the customer service demo, and then several others related to governance. So if you would please run the demo.
I'm going to show you how Watson can really start to transform customer interactions. I'll play the role of a customer of a fictitious insurance company called FlexRate. I've just been through a significant life event. I've just got married, and I have some questions about what the implications of that are on my insurance coverage. I could call FlexRate's call center, but I'd rather just open the FlexRate app on my cell phone. Integrated into the app is an instance of Watson, so let me go ahead and tell Watson what's on my mind. I just got married. Watson's able to start invoking the right set of processes. It also customizes and personalizes the response to me. Watson now wants to know what my spouse's name is. Joanne Campbell. Watson's asking for permission to ask a few questions to get the process started, to which I'll say yes. And it's noticed that I have a homeowner's policy and wants to know whether or not Joanne will be moving into my home with me. I'll say yes to that, but I'll say no to the question about auto insurance policy. But yes, I would like to reassess my needs about life insurance, but not right now. Let's schedule a later time. It's usually best to get me in the evenings. And my cell phone is usually the best number to get me on. Watson then summarizes his information back to me and gives me an opportunity to change those details should I need to. Watson wants to now move on to talk about homeowners insurance. It asked me a question about whether or not my wife will be bringing high-value items into the home, and she will. So now is a good time to review my personal belongings coverage. Watson summarizes this for me, and it gives me the opportunity to change my coverage. I'm going to elect to double my personal belongings coverage from $50,000 to $100,000. Watson now updates my summary of coverage, and you can see that my premium has gone up to $133 a month. That looks good. We'll accept those changes. So far, so good. But what happens if I have a follow-on question? What happens if I have a question that Watson hasn't prompted me for? A question which is off script. I can ask Watson a question in natural language. In this case, I'll ask, what are the jewelry coverages? This is a question which Watson hasn't prompted me for, but Watson's able to understand the meaning of the question and find a response to that question within its corpus, within its body of knowledge. I have a follow-on question. My wife's diamond ring is worth $3,000. Can I get additional coverage for it? Watson takes this complex question asked in English and searches his corpus for the correct response. In this instance, the correct response is about a rider being required for this high-value item of jewelry. That's it, I'm done. Watson's been able to answer the questions that I had, and it's been able to walk me through the processes in order to complete the actions which were required. In all, a highly satisfying experience.
The key here is in a government service environment, this could just as well have been an individual who was seeking to renew their driver's license, who was renewing the registration on their vehicle, or who was going to ask questions regarding paying their taxes. Now, in the public sector, which you all respectfully represent, this is an important capability. And I actually am going to, in a moment, take control of the system again and do two different demos. One I had not planned, so there's always risk, and you'll have to bear with me. I'm going to reach out to two different countries, two different nations, and actually work with live instances of Watson. The first one I'm going to show you, which I had not planned on, is actually a public service that was literally just stood up in the nation of Singapore. Their Ministry of Finance actually has stood up an instance of Watson where you can log in and you can actually ask questions related to your taxes. So I'll do that, and after that, I will log into an instance of Watson that is running in London, in the United Kingdom, and I will use that to solve a criminal investigation, which I will explain in a moment, about a particular series called Breaking Bad. Now, Breaking Bad, just to give you the background, it's a challenge. If you want to show a criminal investigation, I can't violate everybody's privacy by showing public data that's real. But it turns out Breaking Bad is a television series. And that television series has completed, so all the facts are done. Somebody went through the trouble of entering all the facts about Breaking Bad into Wikipedia, the online encyclopedia. What we did was we literally took all of Wikipedia and fed it to Watson. So it internally has all of the information in Wikipedia, including all the information about Breaking Bad, so I can actually demonstrate how you would utilize it in a criminal investigation. So in any case, let me do the live demos I've just described, and I would ask the team in back to please transfer control back to my system. Thank you. Now, the government of Singapore decided they weren't going to say ask Watson, so they're now saying ask Jasmine. And this is a beta. This literally was stood up in all seriousness, as far as I know, about 5 days ago. What happens is we're actually in the process of helping train Watson. And so I will read these because it's going to be difficult. And in fact, let me re-ask some of the questions I've worked with. One question I'm going to ask is, what gift may I give before it is taxable? It's a reasonable question for a tax authority. And it instantaneously comes back with a single answer. It says, whether taxes payable on a gift for a special occasion depends on the type of occasion and the amount of the gift. For bereavement gifts, in the event of a death, the amount is not taxable. For all other types of gifts, for special occasions, gifts under $200 are not taxable. Gifts over $200 are taxable and have to be declared. Instantaneously, it only gives a single answer. If you want to then try something a little more complex, you, for instance, could say, may I speak to a tax officer? And typical, it argues with you. It says, I am a virtual assistant and I can help you with your individual tax needs. But if you want, if I'm unable to answer your question, you can contact our service representative, and it gives the numbers. This is actually running live in Singapore, and although we're demonstrating it on stage here in Dubai, the point of this exercise is this will learn, because if you ask a question it does not know the answer to, what it does is it simply takes that as your input, and then it sends back that to the actual tax advisors who correct the machine, and the next time it has the right answer. So you're actually seeing a system in training. It is not fully operational yet, but it is being trained. Now, without further delay, what I want to do is I want to bring up an instance of, there we are. I want to bring up an instance of solving a criminal investigation now using Watson. We've done this two ways to show the difference between traditional search, which might be used by an investigator, as opposed to using Watson. I will start with just traditional search. This is again related to Breaking Bad, and the investigator's name is Agent Schrader. Agent Schrader has found there was a new drug on the streets called blue meth, methamphetamine. a stimulant that is illegal. So he's interested in that, and he types in blue meth. Aha. And search immediately produces 3 hits. James Alkene, I won't go through reading his information. He came up because he has a blue tattoo on his neck, so that's not relevant. But it did find blue meth, and it found one other entry, blue bloods for blue. So what I'm going to do is I'm going to select blue meth, because that is the one we're interested in, and I'm going to ask it to display it, and all the information search can find relating to it on the screen. So it has found 2 other facts. Related to blue meth is a person named Jesse Pinkman. Turns out he was arrested for possession of blue meth. So this is the person who actually they found with the drug, and he told the police about somebody named Heisenberg. Heisenberg is the supposed manufacturer of the drug. This is the person you want to find and get off the streets. The trouble is, in search, this is all you know. However, now I'm going to invoke Watson. So I'll turn on Watson, and I'm going to ask Watson a simple question. And I'm going to intentionally ask the wrong question. I'm going to say, who is Heisenberg? Now, the reason that's the wrong question is, whoops, I also have to spell it right. If you ask who is Heisenberg, Watson is a smart system. It'll actually look him up. Heisenberg is a physicist who invented something called the uncertainty principle. That's really not what you want to know. What you want to know is you really want to ask who uses the alternative name Heisenberg. Because obviously this person is hiding their identity, and you instantly, thankfully, you instantly get the answer, Walter White, who is the character in Breaking Bad, who is in fact the meth cooker. Now, you have to establish that, and by the way, here's an interesting aspect. This is how you know you're not dealing with search. Instead of saying alternative name, we actually know it's a false name. Right now, the probability, it says, of being correct is 72%. If I simply change and really am specific in my question and say, now the confidence has risen to 86% because it knows this person, Walter White, is hiding their identity. Now, I can actually ask Watson, where did you get all this information? And it instantly will show you that it looked through all of Wikipedia, and everywhere something related to this person or this drug came up, it actually highlights it and then goes and checks further connections. So there's a vast amount of data it has on Walter White. So I'm going to now ask it to show me that data on the system, and it's going to do that, and I'll shrink it so you can see it. What it's done is it has taken all the information it can find about Walter White and displayed it in a way that you can actually look at it on a screen. And it has some interesting things in it. For instance, if you look at all the facts about Walter White, there's one over here that says he's a chemistry teacher. Now that's interesting because you're worried about a chemist making methamphetamine. Now what you can do, though, is what you really want to know is how is Walter White connected potentially to the person who was caught with the drug, Jesse Pinkman. Instead of asking questions, I'm just going to click on it, and it is going to eventually sort this out. I can actually accelerate the process. I have one that's already finished sorting. Here we go. And what it does is interesting. It takes all the information related to Jesse Pinkman, and it separates what's unique to him here and what's unique to Walter White at the bottom. But it turns out there's a tremendous amount of information that is common to both people. And this is how you know that they are both connected in some way in this criminal activity. This is something where if you look at the amount of information that was gathered in about a second, this would take a typical investigator the better part of a year to discover this. Furthermore, you can look at any of these pieces of information. For instance, they were both connected to a murder. If you do that and click on it, it gives you this whole host of other references. This is an incredibly powerful tool. It is looking through a vast amount of data and instantly giving you information that would take a person a year to develop. So this is just one example of how you can, in fact, utilize this kind of capability in a government setting, particularly here, as I said, you're working in the area of basically solving criminal activity. So if we could now, thank you, go back to the mainstream presentation, if you would. Thank you. Healthcare. Now this is, again, a rather extraordinary field. In healthcare, if you really think about it, this is a place where a company like us, we will basically choose to make our first, how should I put this? We'll make our first investments here. The reason is healthcare is a place where data has a profound impact. And I'm going to tell you a story about one case, very specific case that is a wonderful example. We used to call this data baby. There is a crisis for young premature infants. If an infant is born prematurely, it has a poorly formed immune system. Now, when you catch a cold, the reason you sniffle, the reason you cough is your body is defending itself. But these children, these premature infants, they have no defenses, so you don't know that they're infected until the infection is so bad that it actually causes their organs to collapse. The sad thing, therefore, is the baby, when examined by a doctor or a nurse, is healthy, dead. The phenomena has a name. It's a very sad name. It's called baby crashing. And it is incredibly depressing to the medical community because there is no warning because this child does not have an immune system. We were asked to help, so we worked closely with the University of Toronto and the Sick Children's Hospital there. What we did was, for an entire year, we took 2,000 pieces of data a second for every child in this intensive care unit, the premature infants. 2,000 a second, vast amount of data. When one of these children sadly became infected and died from an infection that they acquired in the hospital, what we did was we looked back in the data for anything, any sign that would warn us earlier that this child was in trouble, and we found them. You can't see single things, you can't see double things, because as a nurse or a doctor, these things that are indications can be so subtle, they're invisible to the naked eye, but not to the computer and not to analytics. And what we found was we could correlate fluctuations in blood pressure, blood oxygen, heart rate, the change of heart rate, even though all of the numbers were in the normal, healthy range. Just from these very subtle fluctuations, we were able to predict this child was septic, was infected, 24 hours before the doctors or the nurses could see this, which meant you could treat the child with a heavy dose of antibiotics, of antiviral medicines, and save the child's life. You know, at the end of the day, that's what it's about. We use technology for the betterment of society, for the betterment of our people, for the betterment of governance. And that's an important demonstration, and this is big data, but it's taken another step forward. In the most remarkable implementation, it is being used in very large hospitals now. It is well along in its trials in treatment of many diseases, and what I'm going to show you now is a last demonstration of actually a live demonstration based on Watson being done in Memorial Sloan Kettering Hospital in New York. So here is the video. I'm going to interrupt the video at the very beginning because the video begins with the result of the actual competition Watson was involved in.
Watson, who is David McCullough, correct?
IBM's Watson, the technology that beat two.
I've stopped this here to show you the actual result. After all the fear and all the head-holding during the development of Watson, those are the final scores. These are the two actual champions ever in Jeopardy! One of them won more than several $1 million in this game. The other one won over 70 consecutive games. These are brilliant, brilliant individuals. But Watson defeated them by about a factor of 3. Now, before somebody worries about computers taking over the world, I should normalize this. You see, Watson won by a factor of 3, but it was using 80,000 watts of energy. A human in their brain only uses 20 watts, so clearly we had a much better designer than the computer. So I wouldn't worry yet. So moving along, I know I always get that question. I figured I should answer it in advance.
Humans on Jeopardy 2 years ago may be the technology that helps doctors beat cancer. Dr. Arthur Forney at WestMed Medical Group in New York is testing Watson in the form of an iPad app during its pilot phase.
So here Watson was given a very unusual case, a young Asian woman, non-smoker, who has lung cancer.
So now you tell Watson to do its thing, and it's now looking at the data you inputted, the data from her imaging, from her biopsy.
In 17 seconds, Watson has analyzed about 3,500 textbooks and 400,000.
I stopped it again. This is what Watson is about. 17 seconds, it analyzed 3,500 textbooks cover to cover and another 400,000 data sets. It is not that it is smarter than humans, but humans do not scale. There is no way in the world that I could ever ingest that quantity of information. The average physician in a month reads 5 papers, not books, papers. And that's not a criticism. They're incredibly busy saving lives. This is where the computer is a tool to help you save lives. It is a tool. It does some things way better than we do, other things not as well. But it's important to understand the difference.
Other pieces of data.
This is the screen where it shows you that after looking at what you have so far, it would consider that you would do several other things for the patient that it doesn't see yet in the chart.
In an instant, Watson has figured out what caused this cancer.
It turns out she has a very rare genetic mutation, which is accounting for her cancer.
And offered 3 treatment options.
It has shown that treatment 1 has a 95% confidence of being effective, whereas treatment 2 is only half that.
Is this so obscure that you would have needed Watson for the diagnosis and treatment, or would an oncologist come up with the same treatment plan?
In fact, this is such a new discovery of this particular mutation, and it's a relatively new drug as well, that my guess is that many oncologists may not be quite up to speed yet.
Watson gets its wisdom from Dr. Andrew Seidman and a team at New York's Memorial Sloan Kettering Cancer Center. 1,500 lung cancer cases so far, and breast cancer cases as well. Lab results, physician's notes, and clinical research have been fed into the supercomputer, along with medical journals and textbooks.
We are trying to challenge Watson right now in the training process with common cases and not so common cases.
So the Watson system that we built is a machine that's about this size. We've done a lot of engineering on that since then. So
Watson Chief Technology Officer Rob High says the achievement is staggering.
Watson learns about language, and that's the really profound breakthrough here, is that it is in the language that we understand each other.
That breakthrough and Watson's remarkable accuracy could help doctors eliminate unnecessary procedures and costs and disrupt the $2.8 trillion healthcare.
$2.8 trillion healthcare system. Right now, the estimates in the US are up to $750 billion of those dollars are wasted because we simply don't have enough data. We're repeating tests that are unnecessary. The point is, this can be transformational. If we could go back to the mainline presentation, please. Thank you. We have many, many partners. It's not just one. There are many physicians. There are many universities. So Watson is really well established at this point. It started off as an R&D project on the left. The demonstration was a success. And at this point, we have a full group. It's a $1 billion investment for IBM, in addition to the $25 billion for the analytics up front, $100 million for venture, and we have built a New York headquarters. So to sum this up, the innovators of tomorrow will be able to do amazing things, but they must be able to work with big data. They will be using analytic tools as commonly as we use a pocket calculator. They will be a standard thing that we count on. Cognitive systems such as Watson will absolutely change the way in which we provide services to our citizens. It will fundamentally and dramatically improve them. But at the end of the day, we all have a responsibility to use these assets, the entire IT industry, you as the governance of society, in order to improve the human condition. And I have absolute faith from what I've seen that you will do a superb job of that. Thank you for your attention.